let's talk about asynchronous JavaScript. What asynchronous JavaScript means. So let's first of all present a problem. So imagine that we have a function. So function f1. So that function returns content after, for instance, 1.5 seconds. So if I do set timeout, right? Set timeout. So then after 1.5 seconds, I want to return something. Yeah? How do we do that? Let's first of all create a callback function. So a callback function is essentially, you remember higher order functions? I'm going to create a higher order function as an argument. I call it callback. So then here, after 1.5 seconds, I can do callback and then with the message, hello. Yeah? So then, can anyone tell me how do we print hello after invoking F1? Console log. Like that? No. How do we do that? It's a question on the intermediate.
Recording?
Yep.
All right. Would you first have to call the function and then call the function within it?
Call the function and then call the function within it. How we do that, Itamar?
All right. So function and then function 2 inside the parentheses.
Function 2 inside the parentheses. Function 2 like that. And then what?
All right, no, set timeout and then parentheses.
Set timeout.
Yeah.
What set timeout? No, I don't want to use set timeout, right? Set timeout is already part of F1. I just want to capture hello message.
All right, wouldn't know that. Sorry.
Right, I'm going to wait until someone gives me the right answer, right? Because this is not even part of this workshop. This is just, yeah. Function 2, yeah. Function 2, and then like that? No. Replace.
Yeah. Console.log. So they are passing console.log function to F1. So that's the callback parameter in there.
Like that?
No, you don't need the braces.
Like that?
I think so. Hang on. Yeah.
Right. Really? No one knows how to do that? Inside the bracket. How we do that, Poppy?
So you can just put the function inside.
Function inside.
You have a function can invoke a function.
Like that?
No.
No?
No.
No.
You name it.
Rename it.
You wouldn't name it.
Right, I'll name it. How you want to name it? Poppy? Poppy.
Yeah.
And then what?
Bracket.
Bracket. $10 points. I promise, I'm not going to do anything else, right? Because I was assuming you already know that. If you don't know that, just it doesn't make sense to continue, right? So this is mandatory to continue with the workshop.
Hi, Ricardo.
Hi, Bala.
So, just want to double check. So, you want a console log out?
Yeah, I want the console log. Hello.
Sorry. Is that the intention when we call that?
Yeah. So I call F1, and F1 after 1.5 seconds will return hello.
And it should console log out.
Correct.
Are we allowed to use the
Okay. Yeah. Correct. So, Ricardo.
Yeah.
F1
Yeah.
console.log. Hello?
Yeah.
I can't see it. So the YouTube is, no, it's a little bit laggy. Sorry, just a moment. Let me get to the live mode. I'm not. Yeah, console.log in brackets.
Parentheses.
Yeah, parenthesis. Just give anything, X or something.
X.
Yeah, console.log in brackets. Parenthesis. Yeah, parenthesis. Just.
Can you mute the YouTube video, Bala, if you don't mind?
Sorry.
No, that's all right. I hear my voice like 3 times because of your speakers, because of YouTube. So could you please mute the YouTube video? Right, guys, that's not correct, right?
Just give me a moment. Sorry, I need to.
So, Bala, could you please mute yourself?
Trying.
Thank you. Instead of console log, so Rafa is suggesting to type callback. And then the parentheses. And then what? What is the console log? I want to display a console log, right? Console.log below hello. Now, I don't want to change the function, right? The function is a black box. Below callback afterwards? Yeah. Console.log brackets. Yeah. Parentheses.
And the callback.
Callback?
No, the hello. The string.
Hello?
The string, sorry.
Oh, yeah, but I don't want to hard code it.
Yeah, but you read my hand, it doesn't make sense.
Yeah, I want to return whatever the function, whatever you put here, right? Yeah. Hello, that text. I want to display that text.
Console.log set timeout.
Console.log set timeout. Yeah, but then we're copying and pasting the same thing, right? I just want to invoke F1.
Can you do F1 console.log parentheses callback parentheses?
Console.log.
And then you put the callback and parentheses, something like that.
No, wrong.
Okay.
You get why I don't want to progress? Because if you don't understand that, yeah, that's it, right? Let's do something else. Let's stop the video and then let's do something else.
Let's do something. Hi, Ricardo.
Hi.
Sorry. Did I finish? Do you hear my answer?
No.
So, okay. So I said F1 console.log X, in parent.
X.
X.
Yeah, but that's wrong.
Yeah, that's wrong.
What's X? X doesn't exist, right?
No, but that's the function we're passing to the callback, and the callback will invoke that with a value. Hello.
I mean, let's just run it, right? Let's see what happens. Let's run it. Yeah, it doesn't work, right? X is not defined.
Okay.
Megan. So Megan says, can you say it again, Megan? Function callback. Not inside. Where? Outside? Function callback. Square brackets. Wrong. Yeah, Ashley, please.
So
F1. Function. Sorry, Bala. Sorry, Ashley is talking now. Wait a minute, please. So, function and function what, Ashley? Parentheses.
and then transfer, and then open the curly braces, and then you console.log F1.
¿Vale?
Yeah, so essentially we have put the x in that function parent x, console.log x.
And what else?
We need to return in the function, return console.log.
Yeah, well, we don't need to return it. So console.log will print something immediately, so that's fine.
Okay, yeah.
Still red. Why is it still red?
Because I haven't
Close
closed the parentheses.
the parentheses.
But we need to close the parents, yeah.
Yep.
Yeah, and yeah, that's it. I mean, put a semicolon after console.log.
Correct.
Yeah.
So that's correct. After 1.5 seconds, gets display. So there are 7.5 points for Bala and 2.5 for Ashley, because at least he got some good idea about how to do it, right? Cool, thank you guys. Thank you, Bala. Please mute yourself if you don't mind. I'll give you some good points afterwards. Cheers. So, yeah, that's the way you deal with callback functions, right? So, after wasting 30% of the workshop explaining something that I was assuming you already know, right, let's continue. So, that happens when we have one function, f1, right? Obviously, we can, if you want, use an arrow function here, right? If you want to make it a bit, more trendy, if you want, you see, after 1.5 seconds, it displays hello, right? But then, what happens if we have another function, f2, and f2, after 2 seconds, displays world. So, not 2 seconds, 1 second. After 1 second, we display world. So, can you tell me, I need to make the code a bit smaller, unfortunately. Can you tell me the execution order? So, I'm going to add a few breakpoints now, line number 3, 4, 9, 10, 14, 15, 18, 19. You see? 3, 4, 9, 10, 14, 15, 18, 19. So can anyone, apart from Bala, because he already got lots of points today, so apart from Bala, can anyone tell me what's the execution order?
Yes, Ricardo.
Yeah, Mo?
Cafe. Yes, yeah, well, so 14,
14,
18,
18, question mark. Right.
wait,
Yeah, Jeff.
so
Sorry, Mo. It's Jeff's turn.
14,
14.
I haven't finished.
14, what else?
14, 15, 3, 4,
14, 15, 3, 4,
18,
18,
19,
19,
9, 10.
9, 10. Mo, can you finish? You want to finish, please? 14, 18?
Yeah.
Yeah. What else?
I've got to think this through, man. Just give me a bit of time, give someone else.
Okay, so anyone else? So you go with Jeff. So we got Jeff and Dave. Daniel.
14,
Daniel says 14,
3,
3, 4, 15, 18, 9, 10, and 9 again. 19, sorry. So Daniel, Rafa, Poppy. Anyone else? Megan, Michael, Mo, Megan. So Megan says 14, 18, 3, 4, 15, 9, 10, 19.
Okay, so my answer. So,
Mo?
slight multiplication. 14,
Yeah.
3, 4,
14,
18,
3,
Yeah.
4, 18,
9, 10,
9, 10,
19,
19,
then 15.
10, 15. Right. I think you are all wrong, massively wrong, actually. Right? Please, guys, this kind of exercises are important, and you'll never get them unless you practice. Yes, you can try, Ashley. 14, 3, 18, 9, question marks. Right. Rafa, you already give your answer, right?
Ricardo, can I try?
Yeah, Itamar, you can try. You're the last one that can try, actually. Yes.
Okay, let me just look at the breakpoints again. Okay, so I found first.
Yep.
15?
Which one? 14?
15.
15 first.
Yeah.
Okay.
Then.
That's wrong. That's it, Itamar. That's wrong. That doesn't make sense, right? So let's leave it here, right? Because it's wrong. Cool. I'll give you what I think is correct. And again, if I'm wrong and someone is right, you get lots of points, right? Bala, no, you're not allowed. You got 7.5 points today. That's it for today. Bala, sorry. Let's leave it. Let's leave it here because otherwise we got 12 minutes left and we haven't even started to talk about promises. Sorry about that. So what I believe, I agree with Ashley originally. 14, 3, 18, 9, and then we start with the complicated aspects. I believe then we got 10, and after 10 we got 19, and after 19 we got 4, and after 4 we got 15. This is what I think, right? So unless I'm wrong, I could be wrong perfectly. Yeah, but okay. But let's see if that makes any sense. Let's run it. We started 14. I don't know why Itamar thinks we started 15. That doesn't make sense, right? 15 is actually the last line, probably, right? Because that's, at the very end. 14. Then, because we're invoking F1, then we just call F1 synchronously, right? So next line should be free. Correct? You see? So pretty much everybody apart from Mo and Ashley are wrong already, right? After running that, because this is asynchronous, we'll go down to line number 18. Correct? And then, so now Ashley is the only one that's still alive, right? And after 18, then we invoke F2 synchronously, so we run 9. And now, that's the tricky part. We'll wait for 1 second, and after 1 second, why 1 second? Because this is 1 second, this is 1.5 seconds. It's a race condition, right? Line number 10 will run half a second before line number 4, right? So Walt will run before. After 1 second, look. That's it. 10. And after half a second, no, sorry, no, not after half a second, no. So now, because we're invoking the callback, we're immediately, running the callback on F2. So we should immediately run line number 19. Here you go. And now, after half a second, no more, no less than that, it will run the callback on line number 4. What is 4? Did it time out? Right, let's try again. Yeah, okay. Right. Come on, Chrome. It's so unreliable. I'll do something. I'll create a new snippet because this is completely inconsistent, right? I mean, I could be wrong, but if I'm wrong, I'm consistently wrong, right? And I run it twice and it throws different results. So let me create a new snippet. And let's try again. 3, 4, 9, 10, 14, 15, 18, 19. So let's try again, guys. 14, 3, 18, 9. Now, 1 second. What is it? Come on, Google. Yeah. That doesn't make sense, right? So this is one of the horrible things of recent versions of Google Chrome. It suddenly stops working, right? And actually, not even the console logs are displayed anymore, you see? Right, this is pretty inconvenient, and I could solve the problem by restarting Chrome, but then, because the guys are using Hangouts on Chrome, right, so then they will get disconnected. I will disconnect, right?
Are you using an incognito window?
I'm not using an incognito window, Bala, but I can try. That's a good point. Let's see if on incognito, that's a good point, Bala. Let's see if on incognito it helps, right? So, right, new snippet again. Let me run it first without any breakpoint, just to see if it works. Oh yeah, okay. So then let's set the breakpoints. Yep. So let's see if now it makes sense, right? I think I've lost what I said, but again, let's redo it again. 14, 3, 18, 9, and now after 1 second it will run 10, right? 1 second. Here you go. Thank you, Bala. You were right. So, and now immediately we should run 19. Yes, and now after half a second, this is the part we missed before, right? On the non-incognito. We should run which line after half a second, guys? Which one? Dave? Yeah, Dave is right. After half a second. Yeah, okay, let's ignore that, guys, because it's just pointless, right? I can add the debugger if that any helps. But yeah, I think it's very hard to present the example if the breakpoints are not working as expected, right? You see? Now they are not running anymore. But yes, anyway, yes, after half a second, it will run the callback, and then eventually it will execute the last console log, right? So that's the way this works. So let me then, I'm going to open a new incognito window because it's very sensitive. DevTools is very sensitive with asynchronous code. So let me create a new snippet. And then, so that's the way we work with asynchronous code. But now, question for you, and I'll try to, let me see if it works. I'll try to ignore breakpoints because, yeah, it just doesn't, that's wrong as well, right? So, look, let me see, hello should be displayed way later. Now it's correct. You see, after, well, correct, is that correct? Is it waiting for 4 seconds to display hello? Let's have a look. 1, 2, 3, 4. Okay, maybe. Yeah, okay. So let's assume that that's correct again. So now my question, guys, is if we run that, the original example, what message will be printed first? Hello or world? Which one?
What was the question? Sorry.
The question is, what message comes first? Hello or world? Right, now it's going to be hello, correct, because I changed the timer. But if we put it back to 1.5 seconds, which one comes first? World, correct, right? Yeah, I don't believe there is half a second between these two messages. I may be wrong. Maybe yes, it's a visual feeling. Do you think there is half a second delay? Look, between hello and world and hello, look. Oh, now it looks correct. Anyway, yeah. I'm going to stop using that tools at some point, right? Yes, doesn't work. But anyway, so that's the way it works. But what happens if we change the question and we want to have a sequence? So we want to display hello first and then world. How do we control that? Does anyone know how to change the code to display first hello and then world? Yeah. The time is what it is, right? Let's say that you don't have control. We're invoking the backend 2 times. We don't know which request will be resolved first, right? We don't know that. But we want to make sure that we invoke the F1 function after F2 got resolved.
Promise, isn't it?
No if else, no promises. We'll talk about promises later on. No, guys, what I want to do, yes, Ashley? Yep. Yeah, that's correct. Ashley is right. Ashley is completely right. F1, and just after if F1 is completed, then I will call F2. You see? So now, regardless of how slow or how fast F1 is, because we are not invoking F2 until F1 is completely finished, we make sure that the sequence is correct. So look at what happened now. Even though F1 is slower, it takes half a second, 50% more to complete, but we won't start rendering F2 until F1 is completed. So that means after 1.5 seconds, we'll get hello, and after 1.5 seconds plus 1 second, that means 2.5, yeah, we get world. Let's have a look, guys. 1.5, 1 more second, yeah? That's the way you can chain functions. And what if we got F3? The same, right? F3, so let's guess that F3 is even quicker. F3 will take just half a second, right? Super fast function. So F3 takes half a second, and that will display Codery, right? For instance. So then, hopefully you can figure it out, right? We can chain them, yeah? F3. So can you tell me the execution order now? So Daniel, 20, 21, 20, wait a second, I wanted to put that inside, right? That was my fault. I wanted to put F3 inside of F2. Yeah, indentation is horrible, by the way. Anyway, something like that, right? So, yeah, correct. So Daniel, 2021. That's correct. You agree with Daniel? Yeah. Now it's a sequential order, right? Let's have a look. 20. After 1.5 seconds, 21, and then 22, and then after some time, eventually 23, or Google breaks again, right? That was the alternative, right? So I'm not going to add any other breakpoint today, because as soon as we add breakpoints, we ruin it, right? Yeah, no, let's stop putting breakpoints. See if I can create a new snippet without killing the incognito window. See if that works. Nah, it doesn't. I need to kill incognito again. Right, so let's do that. So let's open a new incognito, inspect, and then sources, and then new snippet, and then without any breakpoint, you will see it will display F1, F2, F3, hello world, code80, right? So that's correct. That's actually correct, right? Right. So that's the classic way of handling asynchronous code, nesting functions, one after the other. Yeah? F1, then F2, then F3. But hopefully you can guess that this code is hard to maintain. This is what we call the callback hell. Have you heard about callback hell? There are some good pictures in Google about that. JavaScript callback hell. JavaScript, right? You see that? That's a classic problem of a bad architecture in JavaScript, right? I'll show you my favorite picture ever. Yeah? Callback hell. Don't do that. Because of that problem, I mean, that problem has been there since 1995, to be honest. Then, someone, long time ago, thought that there should be a better way to host or to manage this kind of asynchronicity, right? Someone created the queue library. Long time ago. It is a very popular library to solve the problem. So he called it promise library, right? So promise library is something that that guy probably made up, but quickly became very popular, very, very popular, right? Based on this quite complex implementation, firstly Angular in 2011, as part of the framework, they introduced $Q. That was a subset of Q, but it was great because if you use Angular, by default, out of the box, it was much easier to deal with asynchronous code, right? We, in 2011, we were already using lots of HTTP requests to the backend and things like that, right? So that was pretty good. And later on, because the popularity of promises just keep increasing, then JavaScript decided to incorporate it into the standard, which was great, right? So now that means that, well, that's a bit over-optimistic, but you don't necessarily need the library because it's part of the standard, right? To be honest, the standard is just a subset of the Q library. So if you need some more complex, advanced usage of promises, you may still want to use it. But for the majority of us that we just want to do 3-4 callbacks, 3-4 functions to handle synchronicity, you know, that's enough, right? So there are new proposals to promises. Maybe you've heard about things like generators. So there are some proposals out there, right, to extend, enhance promises. So essentially, people complaining about promises, people who defend generators, they say that promises essentially have two main issues. The first issue is you cannot repeat a promise. So once a promise is resolved, that's it, right? With generators, you can re-trigger the promise, the generator multiple times. The second problem is you cannot cancel them. So once a promise is triggered, it will be either resolve or reject, but you cannot stop it, yeah? But anyway, that was beyond the scope of this session. Yes, for today, for 2011, yes, you know that obviously we got promises. So what a promise is? A promise is a different way to organize, to orchestrate your logic. So I'm going to refactor the code using promises. First of all, instead of passing a callback function, we don't need to pass anything. So let's remove the callback function. And then what we do is we return new promise with at least one argument. Resolve. I told you she doesn't like promises. So with look at the way I'm refactoring the code, right? So now instead of calling the callback, I will resolve the promise. Yeah, return new promise. I need to type 2 more lines if you compare them, right? But as a positive side effect, I don't need to pass any argument. So if I want to pass any argument, it will be a proper data, numbers, strings, arrays. I don't need to pass a callback function. I don't need to pass a higher order function. Yeah. So under my point of view, the code becomes a bit cleaner, I believe. So let's refactor our 3 sexy functions from callback to promises. So if we do that, now we obviously need to change that, right? Because that's what we wanted to avoid. We wanted to avoid to have this kind of complexity, so many indentation, right? Look at how sexy now the code becomes using promises. Now you can do F1 dot then yep, and then dot then yep. Sorry, not console. Yeah, I wanted. Sorry. So F1 x console.log x. Sorry, let me ignore the console logs for now. Otherwise, it will be a bit more complicated. So the most basic example is doing that. So let me refactor that a bit, right? So now that's the way you invoke the functions, right? You can see that it's much easier to read because even if you have 50 sequential functions, dot then, you see, right? You can see that that strategy is like playing with arrays, dot split, dot filter, you see? So with promises, it's pretty much the same thing. So that code becomes essentially way more readable, way more readable. I would like to add breakpoints, but you know how Chrome is today, right? So I'm scared of breaking everything by putting breakpoints. So instead of putting breakpoints, I'll do something. I'll do a console log. Right, so I'll do 2 things.
Quick question.
Yep.
So how do we net the catch statements then, if we are doing multiple then?
I'll check. I will talk about catch in a minute. Let's first of all, so this is the happy path. Happy path means let's assume that all the promises get successfully resolved. Yeah. Again, you know I'm not a big fan of console logs, but this is just a fallback because of all the problems using breakpoints today. So, if we run this example, you will see that even though F3 is the quickest method, it takes just half a second, yeah? You will see that even though it will run codedy, console log will run last. Look. Hello, world, codedy. You see? So we've managed to keep the order. And more interestingly, with promises, it's very easy to chain data. So the output of a function easily becomes the input of the next function. For instance, let's display F1. When we invoke F1, we're going to pass some of your names. So first of all, I'm going to pass Dave. So that means F1 will receive a player. And then, look at what I'm doing. So at the time of resolving F1, I'm going to pass Dave plus space plus someone else, Michael. Yeah? And then, so that's the output of F1 that will immediately become the input of F2. So here I got a list of players, right? So I can do the same thing, right? Players plus Rafa. Yeah? You got the idea, right? And this is the output of F2 that immediately becomes the input of F3. Same thing again, and again, right? So then we can do, let's get rid of the console log. So we can do resolve players plus Luna. So how do we display the last message? We can obviously at the end do .then final message. You can obviously rename it, right? Console.log. We can call it players if you want. The list of players is players. Yeah. So you see, we pass Dave as the argument of the first function, and then we'll pass Dave plus Michael to the second one, and then second one will take Dave plus Michael, and it will take it, and then it will add Rafa to F3. F3 will take Dave, Michael, and Rafa, and it will concatenate Luna, and Luna will be displayed eventually. Let's see if that's correct. Do you know how long this function will take to complete? That's correct, Daniel. 3 seconds. Yeah. After 3 seconds, we'll hopefully display that message. Let's have a look. 1, 2, 3, 4. Maybe I'm counting too fast, right? But yeah, I think it works, right? Look, the list of players is Dave, Michael, Rafa, and Luna. You see the order is guaranteed because we're sequentially invoking them. Yeah? That's the beautifulness of promises. 2 reasons. First of all, it's very easy to concatenate new functions. And then it's very easy to pass arguments. It's like a chain, right? The output of one step is the input of the next step. Yeah? Can I do that? Look. Can we do that? Right. Let's wait maybe 10 minutes. But that should work, right? Passing, then, same function. At some point, hopefully, look, yeah? Dave, Michael, Rafa, multiple times, right? So it works, right? You see how elegant this code is. Try to do the same thing with callbacks. It will work, right? Eventually, it will work, but you know, callback hell, Street Fighter, Hadouken, right? We don't want that. That's much better, cleaner, simpler. Any question? Right, so this is, as I said, the happy path. So this is assuming that all the different steps in our chain work successfully. But what happened if on F2, no, sorry, let me think about that. Yeah, if on F1, we want to check the name of the player. Look at what I can do now. If player equals Dave, resolve it. Else, reject it. So our algorithm is expecting Dave to be the first player. Why? I don't know, right? Because of any weird and obscure reason. So if player is Dave, then resolve it. Resolve it means send the ball to the next step of the journey. But if not, reject it. Do you know what happened on the promise chain when we reject one of the steps? Stops, correct. Stops. In other words, I think it was Dave with lower case, right? So, can anyone tell me what happened if the first player is me, for instance? If I add a breakpoint on line number 30, no, I'm not going to add any breakpoint. I'll be the breakpoint, right? So I'll tell you where the breakpoints are, right? So there's a breakpoint on line number 30, on line number 3, 15, and 23. So the first line of each method, right? 3, 15, 23, and 30.
It's 30 and the first one, and the last 2 ones are not going to.
That's correct. Rafa is right. So it will run 30, of course, because that's the first line, right? Then it will run number 3. It will stop here. But then, because the player is not Dave, it will reject it. As soon as one promise is rejected, it will cancel the flow. It will stop. So if we run that, you will see something interesting now. Promise, and then, ooh, oh, wait a minute, no, that's a separate problem. You know why we got this error now? What's reject? Reject is not defined. Correct, correct. I mentioned a few minutes ago that promise receives at least one argument, right? But ideally, so put two, right? Resolve, comma, reject. Yeah? Let's run it again. So now, oh, what is my message? It's nowhere. That's still valid. Correct, Rafa is right again. If we want to capture errors, because at the moment that's a bit confusing, right? Imagine that we don't have control. These functions F1, F2, S3 are black box. These are a dependency that we are installing. npm install F1 does the save, npm install F1 does the save. Remember that? npm workshop yesterday? We installed them, so we don't know what's going on. So we are expecting to everything work perfectly, and at the end we expect it to display a console log, right? But that's not happening. Hey, what is my console log? What is it? It's nowhere. So what you need to do is to put .catch, because with .catch, if something is wrong, we can at least print the message, right, and take the corresponding action. So let's see what happens if we run the example again using catch. Look, now it makes a lot of sense, right? Because now we can bring a proper error. Sorry, the first player should be Dave, right? So if we run it again, you will see now, I think I cleaned the console. Let me try again. The first player should be there. And then this is the API, right? Then, oh, if you're invoking, okay, fair enough. So I need to put Dave here. So if I run the example again, now hopefully it will go through the chain end to end from the beginning till the end, and now the algorithm works. So catch, very important, right? Never underestimate how important catching errors is in JavaScript or in all the other programming language. Then, and eventually catch. Any question? Yep.
What is the status for the promises not changing? Is it resolved or is it still pending?
Say it again? Ah, yeah, why it says pending? Yeah. Because promises are managed asynchronously. So immediately after running line number 30, the only thing we know is that F1 returns a promise. That's what we know, right? That's why it says, okay, yeah, there is a promise here. I don't know if the promise is resolved or rejected. That promise might take 5 hours to complete, right? We don't know. We don't know. So for now, what we know is this is a promise. We'll see what happens with it. Yeah?
Hi, Ricardo.
Yeah, hi, Bala.
Right, so essentially, so the catch stops at the first exception and from the function, where any promise that doesn't resolve gives the message, and then we just print that. So we have one catch ever.
Yeah, that's correct. We just need one catch. We just need one catch because the chain of functions will run until any of them gets rejected. In other words, if we reject F3, F1 and F2 will run, but eventually it will get rejected. So we'll display the catch message. We just need one catch message, right? Yep.
Sorry. Hello. Can you hear me?
Yeah.
Would you mind sharing that code snippet on Slack this way?
Yeah. Okay, that's a good point. Yeah, I'll send it on Slack afterwards. Voilà.
Yeah, thank you.
That's all right. So, last thing of the day. In a future session, probably last week, I would like to introduce 2 new and extremely sexy new commands in JavaScript to simplify this a bit more, which are async and await. Maybe you heard about them. So now with very modern JavaScript, this is very fresh, you can do things like that. A sync function, you can do things like that, right? By the first time in history, you can put stuff in front of the function keyword. We'll talk about that last week. For now, the very last principle I would like to introduce is promise.all. That was part of the intermediate challenge. So, in this particular case, the order matters. We want to execute F2 if and only if F1 was successful. And then we want to execute F3 if only if F1 and F2 were successful. Why? Because that's a chain. The output of one method becomes the input of the next one. The order matters. That's valid. That will happen, you know, very often. But in reality, in some scenarios, we don't care about the order, right? We don't care. Why? Because what happens if we want to invoke the backend twice? We want to get the list of challenges and the list of players. These two requests may be completely independent. So we don't have to wait. We don't have to chain them, right? Do you know what's the advantage of triggering two requests in parallel? Correct, performance, right? If we run them sequentially, the algorithm will take longer. In other words, you remember how long this algorithm takes to run? 3 seconds, right? Yeah, and it makes sense because they are related. But what if they are not related, actually? So let's remove the... We can even keep the variables if you want. But let's assume that they are not related at all. So if they are not related, we can do that. We can use promise.all. We can do promise.all, and then we pass an array, that's important, guys, an array of functions returning promises. So we can do F1, Dave, we can do F2, Michael. You can put it in one line, probably, for readability purposes. F1, F2, and then F3, Luna. Yeah? So with promise.all, it's pretty much the same principle. We can do .then. Do you know what do we receive here? A what? That's a callback function, right? So if I would want to do the console.log of the result, this, right? This is the result. So do you know what type of data result is? That's correct, Poppy. That's an array. An array of how many elements? 3. Correct. Correct. The first element of the array will refer to the whatever F1 resolves. The second element of the array will refer to whatever the second function resolves. And the third element of the array will be associated to whatever F3 resolves, regardless of how quick or how slow these functions are. We don't know which function will run quickest, right? We don't know. We don't know. We have no idea. We're invoking the backend 3 times, and sometimes F1 may be quicker, sometimes F2 may be quicker. We don't know. Because we don't know, yeah, at least what we do know is that regardless of the resolution order, the first element of the array will be here, that will be the second one, and that will be the last one. And of course, we can also keep the catch. So we can do all good, resolve, and then catch. Console.log, something went wrong. Result, yeah? The same thing. So let's see what happened if we run the example. Promise pending, all good. Look. Obviously, now the messages are a bit weird because the way these functions are structured. F1 takes Dave and returns Dave plus Michael. F2 takes Michael and returns Michael plus Rafa. F3 takes Luna and returns Luna plus Luna, right? It's a bit weird. But anyway, hope you understand the way it works. What happens if I then pass my name here? What will the function return? That's correct. It will show an error, but do you think that's a hot topic? That's very interesting, because actually F1 will be the latest one, right? In other words, look at the order. It will actually finish F3 first because it takes half a second. Then it will finish F2 because it takes 1 second, and then it will finish F1, which is the slowest one. It takes 1.5 seconds, but F1 will reject it. So do you think the then function will run at all, or do you think it will go to catch straight away? That's correct. That's correct. Let's have a look. Look. You're right. Something went wrong. Sorry, the first player should be Dave. In other words, with promise.all, it will wait until all the promises are completed, and then once they are completed, it will say, okay, do you got resolved? Yes, 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 yes. Just if all the promises got resolved, the entire mechanism will be successful. If one single promise fails, the entire mechanism will be rejected massively, aggressively. Yeah? That's a very important principle when talking about promisings. Any question?
So the model seems to be use chaining for promises if you want them to be or.
Of course, yeah. If they depend on each other, you need to use then. But if they don't depend on each other, look, the previous example took 3 seconds to complete. How long this example takes to run? Why the first one?
Because it will evaluate the first one, and if it fails,
No, but now it works. So now all the promises are successful.
okay.
Yeah, I changed it again, correct. The what? Correct. So when using promise.all, the timing depends on the slowest one, right? So which is the slowest one? 1.5. Because they will be triggered in parallel, yeah? The performance, the bottleneck, is on the slowest one. Yeah, that's how it works. So in other words, now this algorithm runs twice as fast as the previous one. Yep.
Fine, record it.
Yep.
Hello.
Hi.
Yeah, so I think this can potentially be used for the classic map reduce like to distribute computation, right?
Yep.
You can set tasks and gather them back.
Yep.
Okay, so just wondering, I know that's the sort of classic map reduce pattern.
Yep.
But in the JavaScript map or reduce of an array or set of tasks or objects or that kind of thing,
Yep.
that we sort of sequentially iterate over the values.
Yeah.
Within an array, for example, right?
Yeah.
But so within a map function, for example, can we put promises and gather them back?
Not really. No.
Yeah.
No, because all.
Different items, for example, as we go over.
Yeah. No. Be careful with that, guys. So all the array methods, map, filter, find, sum, every, for each, all these things are synchronous, right? So they don't play well. I know there's a bit, we need to play an example, Vala, to prove my theory.
Sure.
But if you have an array, let's say we have an array of 3 player IDs. And for each player ID, oh, thank you, Google Chrome. What's going on now? I didn't press anything. Now it's running the breakpoints I put like 47 minutes ago, right? It took a while to finish the... Right, I've lost the focus now completely. So, yeah, so if you have an array of 3 IDs, 3 players, player 1, player 2, and player 3, and for each player ID, you want to call the backend to get player details, first name, last name, scores, and all these things. Yeah, it could be a bit challenging to use map, and inside of map using a fetch. Yeah, I personally think we will need to do a workshop about that, Bala, because otherwise it's hard to see what are the implications of mixing synchronous code, map for each reduce, with asynchronous code.
Yeah, but that will be great, because if we can nail that,
yeah.
We can use that pattern quite well in any other application.
Yeah, cool. Thank you, Bala. Guys, one last thing very quickly, because we are completely we run out of time, right, massively today. So, what was that snippet? I removed that. What? Right. Where's my code?
Was that in a different window?
This is so fun. Right, so the very last thing, very quickly, a subtle trick. That's also a classic job interview question. So if I got F4, right, function F4, and F4, look, it doesn't have any asynchronicity. It just returns that's it for today, folks. If I want to incorporate that, to the chain of, can you do that? What do you think? Why not, right? Why not? Let's see what happens. If I run it, it does work. And that's fine. That's good. So that's interesting. With promise.all, we can mix synchronous and asynchronous functions. So promise.all is very elegant in that respect. However, what happens if I change them again? Look at what I'm doing now. F1 dot then F2 dot then F3 dot then F4 dot then result. Will this work? Let's have a look.
I think we should stop at then F4.
We should stop. Okay, let's see if that works, right? We'll talk if this is convenient or not. Nothing gets returned, right? Let's put, remember, we need to put Dave as a first player, right? Because otherwise it got rejected. So let's put Dave. 1, 2, 3, 4. Yeah. So that still works, right? So when we chain functions, right? Again, you see that F4 is synchronous, but we can still change everything. However, very last question of the day. We know we can do F1.then. We know we can do F2.then. We know we can do F3.then. Can we do F4.then?
Going by this, it looks like it.
It looks like, okay.
Because the last example was.
That's controversial. That won't work. We saw it work using promise.all. We saw it work using just a sequence of promises. But look at what happened now. This is going to throw an error, guys. Ooh, that's a classic problem. Handling promises. F4.then is not a function. Why? What type of data F4 returns? A string. It's not a promise. There is no promise, right? So even though in some scenarios we can mix synchronous and asynchronous code, we need to be careful with this kind of examples. So do you know how to transform this F4 function into something compatible with a promise chain? In other words, I want to make this example to run, right? I want to make this work.
A new promise.
Correct, yeah, we can do new promise. Yeah, we can do new promise, and we can do that, right?
But at call time, I'm saying,
Say it again.
At call time, convert F4 to a new promise.
Yeah, but I don't want to use new. I don't want to do that. I don't want to.
Okay.
Yeah, we can do that. You're right. If we do that, it will work, right? So we can do return new promise, asynchronous code. But there is a simpler way. If we just want to transform a synchronous function into asynchronous somehow, we can do promise.resolve. Look at what happens if I try it again. You see? Now it works. That's still synchronous. We don't have any callback function. We don't have to deal with resolve reject. But just surrounding our string, our object, our array, then it became immediately compatible with the promise chain. Yeah? Yes, FYI, promise.resolve. And last thing, as we'll be explaining at some point, with very modern JavaScript, we can simplify even more putting async here. Look at how sexy this is, guys. Classic function, error. Async works.
Very cool.
Yeah? So that's pretty cool. Async, we'll be talking about that, right? It's the simplest way to make sure that every function is asynchronous by nature, regardless of whether it takes 1 hour, 1 minute, or whether it resolves immediately. It is, yes, yes. Async. That's pretty much it for today, guys, after 66 minutes of pain. Yes. Yes, she's quite bored already, probably. Anything else, guys? Yes, anything else? No? Cool. That was it for today's. Thank you. Cheers.
Thank you, Ricardo. That was
Cheers,
very
cheers.